Picture this, a lake so sour it makes lemon juice taste like a strawberry milkshake. A place where the water is basically liquid fire acid bubbling, colorful and deadly. Humans, forget it. Dip your toe in and you'll lose your toenail before you can say ouch. Fish? Nope. Plants? Absolutely not. But somehow, tiny microbes look at this acid soup and say, home sweet home. Welcome to the bizarre world of acidic extremophiles, microorganisms that treat the world's most acidic lakes like luxury resorts. These are the survival champions of Earth, the kind of organisms that would win Fear Factor without even blinking. If you thought cockroaches were tough, wait till you meet microbes happily living in water with a pH of 0. That's the same as car battery acid. Yep, life has not only survived in these places, it's thrived. So today, we're diving, well, not literally because you dissolve, into the strangest, most acidic lakes on Earth. We'll meet the microbes that live there, explore their weird survival tricks and ask, what does all this mean for life on Earth, and maybe even beyond? Buckle up, it's going to be one sizzling acidic ride. You're watching Infinitia Verity, where strange science becomes simple. Before we jump into these boiling acid baths, let's set the stage. Imagine Earth as a giant house with different rooms. Most rooms are comfy, like a kitchen with snacks and soft chairs. That's where humans, cats and pine trees hang out. But some rooms, they're like basements full of broken glass, toxic mold, and maybe a crocodile or two. That's where extremophiles move in. Now, what does extremophile mean? The word literally means lover of extremes. These are organisms that adore conditions that would kill almost everything else. Some like it hot, some like it freezing, some like salt, and some, like our stars today, love acid. Where do you find acid lovers? Well, there are natural acid pits on Earth lakes and pools where volcanic gases bubble up, dissolve rocks, and create chemical soups. These places are not your average picnic spots. We're talking lakes in New Zealand full of sulfur, pools in Ethiopia that look like melted rainbows, and mining pits so toxic they could be supervillain lairs. To normal life, these places scream danger, stay away, but to acid-loving microbes, they scream party time. They've evolved tricks to survive where the water would strip paint off metal, and here's the kicker. By studying them, scientists don't just learn about survival on Earth. They also get clues about where life might exist on other planets, because if microbes can thrive in liquid fire lemonade here, maybe something similar can do it on Mars or under the ice of Jupiter's moon Europa. So let's pack our imaginary space helmets and rubber gloves. Time to walk into the world's nastiest lakes. Rising tensions, nature's acid test. Our story begins with volcanoes, minerals, and gases. Picture underground magma burping sulfur gases into water. The gases dissolve, mix with iron, and suddenly, boom, you have acid. Not oops, I spilled vinegar acid, but oops, I melted my shoe acid. In places like Rototai Lake in New Zealand, the water hits pH 4, which is already harsh. That's like drinking orange juice mixed with bleach. Scientists dove into its sediments with fancy gene-hunting tools. They found microbes armed with special gear. Sulfur processing genes, acid protection pumps, and even the ability to kick out toxic metal ions like bouncers at a club. Meanwhile, in Lake Killarney, another New Zealand site, microbes were dealing with high metals and nutrients. Instead of sulking, they doubled down on methane-making pathways. Imagine throwing a barbecue in the middle of a chemical weapons dump. That's what these microbes were doing. Surprisingly, they didn't show many classic metal defense genes. Instead, they just kept calm and carried on. The breaking point, Danakil's fiery playground. Now let's teleport to Ethiopia's Danakil Depression, one of the hottest, weirdest and most alien-looking places on Earth. Imagine Mars, but with boiling rainbow pools. Here lies the Dallol hydrothermal field, where water is so acidic, pH 0 or even negative, that it makes your stomach acid look weak. In 2017, scientists claimed they had found microbial DNA here. The world gasped. Life in pure acid at boiling heat? That's like discovering penguins sunbathing on Mercury. Headlines screamed, life found in hell. But wait, science loves drama. Later teams came back and said, hold on, maybe not. They argued that some pools were sterile, no life, zilch. So now the Dallol pools are the center of a juicy scientific debate. Is there really life, or were those microbes just tourists blown in by the wind. Regardless, the images from Dallol are pure eye candy. Neon yellows, toxic greens, blood reds. They look like Willy Wonka's factory if Willy made acid instead of chocolate. Leaders' decisions, microbes in the acid war. Let's zoom into the microbes themselves. How do they survive? Think of it like a battle. The acid wants to burn through their cells like an army of ninjas slicing through paper. So microbes build super armors. Their cell walls are thicker, their membranes are like Teflon, and they use proton pumps to kick out acid ions before they cause chaos. Some have CLCA antiporters, tiny molecular doorways that swap harmful ions for less harmful ones. Others hoard potassium ions to balance charges, like kids hoarding candy so bullies can't steal it. Energy? That's another battlefield. Acidophiles love iron and sulfur. They eat them by oxidizing minerals, basically turning rusty metal into breakfast. Some also team up in biofilms, forming slimy communities where they share defense tricks. Imagine a fortress made of goo where everyone brings their own snacks. Turning points when science gets creative. Back to New Zealand, scientists used meta-barcoding and metagenomics to peek at the genetic blueprints of these lakes' microbes. They expected dramatic shifts in who lived where. But guess what? Taxonomic changes, who was there, were small. The real action was in functional genes, what they could do. That's like a town where the same people live, but suddenly everyone learns new jobs. Blacksmiths become hackers, farmers become drone pilots. This discovery blew open new questions. Maybe survival in acid isn't about who you are, but what tools you bring. Comic relief, nature's worst spa. Let's pause. Imagine opening a travel brochure. Come relax at Dallol's rainbow pools, enjoy hot springs that melt your sandals, free sulfur smell with every visit. Warning, you may die instantly. Yeah, not exactly a 5-star resort, but for microbes, it's paradise. They roll in acid baths like humans roll in jacuzzis. The bigger picture. Why this matters. So why should we care about microbes partying in acid lakes? Well, 1. Earth's history. Early Earth was full of volcanic gases, hot acidic pools and toxic metals. Studying acidophiles is like digging into our planet's baby photos. 2. Astrobiology. If life can survive in Dallol, maybe it can survive on Mars, Venus's clouds or Europa's subsurface oceans. 3. Biotech goldmine. Acidophiles produce enzymes that work in crazy conditions. Imagine industrial cleaners mining or even making biofuels using these tough little workers. 4. Environmental clues. Acid lakes are expanding thanks to mining and pollution. Understanding microbes here could help clean up messes humans make. In short, acidophiles aren't just weird trivia, they're keys to our past, our future, and maybe our interplanetary neighbors. So what did all these studies and adventures into acid lakes change? For one, scientists realized life is tougher than we thought. Microbes laugh in the face of pH 0, shrug at toxic metals, and sometimes even make methane while swimming in chemical soup. The discoveries also sparked heated debates. Some scientists claim life thrives in the hottest acid pools, while others argue those pools are lifeless. This back and forth isn't a failure, it's science doing what it does best. Testing, questioning, arguing, and refining. On a bigger scale, acid extremophiles reshaped our definition of habitability. It's no longer about comfy, Earth-like conditions. Now, habitability includes neon acid baths, boiling sulfur pits, and lakes that look like alien landscapes. That matters for planetary exploration. When NASA or ESA look at Mars or Europa, they don't just search for Earth-like water. They also ask, could acidophiles survive here? And on Earth, these microbes may help us manage polluted lakes and mines. By studying how they detoxify metals or recycle sulfur, we can use nature's own survivors to fix human messes. In other words, acid extremophiles didn't just expand our science, they expanded our imagination. So here we are. We started with deadly acid lakes, places that look like nature's horror show, and we found life, tiny, tough, unshakable life, microbes that survive in water that would strip paint, melt iron, and terrify chemists. It's a story of irony. The nastiest environments become cozy homes. Acid that screams death to us whispers welcome to extremophiles. And it loops back to a bigger thought. If life can thrive here, maybe it can thrive almost anywhere. Planets, moons, distant worlds, who knows what kind of acid-loving microbes are out there waiting for us to find them. So the next time you sip lemonade and wince at the sourness, remember, somewhere on Earth a microbe is living happily in a pool 1,000 times more acidic. For them, it's not a nightmare, it's paradise. And that's the strange, hilarious, and inspiring world of acidic extremophiles. That's it from Infinitia Verity. Stay curious, stay bold, and subscribe for more.